Okay, so this is number 15 from the multiple choice, and you're given this graph. This is the graph of f, but you're being asked about this function, and right away you should be thinking about the second fundamental theorem of calculus, and what they're asking you is a whole bunch of questions about what's happening at 6. So the first thing you have to consider is what is happening at h of 6. Well, if you replace the x with 6, you're going to get this. This just means the area under the curve of the function f, which is this, going from 0 to 6. Well, going from 0 to 6 would be this region right here, which is, we don't know exactly how much it is, but we do know that it's going to be a negative number. That's what's going to be important to us. Okay, then we need to investigate what happens with h prime of 6. Well, before you can find h prime of 6, you're going to have to find h prime. So we're going to add a prime to both sides. And then you can see that this is now the second fundamental theorem of calculus, so h prime of x is just equal to f of x. Because the second fundamental theorem of calculus says take this upper limit and just put it in where there's t. Okay, so now I need h prime of 6. So I'm really looking for f of 6. Well, the graph of f is right in front of me, and when x is 6, y equals 0. So here's what I know so far. I know that h of 6 is negative, and I know that h prime of 6 is 0. So right now I know that h prime of 6 is bigger than h of 6, because 0 is bigger than any negative number. Okay, I'm going to erase right here. I'm going to erase this to make some more room, because now I need to find h double prime. Okay, so h double prime of x means I'm just going to add a derivative on each side. So if I want h double prime of 6, I'm really looking for f prime of 6. Okay, well, f is this graph right on the page, and what's happening at 6 is the big question here. So if you look at 6, the slope is a positive slope. So we know that the derivative is positive, but we don't know what it is. But what's important for us to note is that h of 6 was negative, h prime of 6 was 0, and now h double prime of 6 is positive. So the smallest number is h of 6, then it goes to h prime of 6, and then h double prime of 6 would be the next one. So that was choice A. Okay, this is number 16, and you were given the starting position of this particle, and you need to know when the particle is at rest. Okay, so a particle is at rest when the velocity equals 0. So we're going to need the velocity, and that's going to require a product rule. So it's the first times the derivative of the second. Okay, so what's the derivative of the second? The derivative of t is 1, and we were told that b is a constant, so the derivative of the second is just 1. I'm not even going to bother writing it. So it's the first times the derivative of the second plus the second times the derivative of the first, which is also 1. Okay, so take the velocity and set it equal to 0. Combine like terms. And all of the choices are in terms of t equals. And that's your answer, and that was choice B. Okay, so this is number 17. You were given this picture of the graph of f, and you were given f of x is the integral from 2 to x of g of t dt, and you need to find what is the graph of g. Okay, so right now it looks like you have absolutely nothing, which is kind of true, but hopefully you're recognizing that this integral looks something like the second fundamental theorem of calculus. So since we have no idea what to do, why don't we just take the derivative of both sides and see if that leads us anywhere. Sometimes you just try things and they just work. Okay, so it became the second fundamental theorem of calculus, and that means f prime equals g of x. Okay, so let's think about this for a minute. This is the graph of f. So what do we know about f prime? Well, the entire thing is increasing. This pink line is increasing. So since f is increasing, then that means that f prime would have to be less, I'm sorry, would have to be greater than 0, right? Because there's a rule that if f is increasing, f prime is greater than 0, and if f is decreasing, then f prime is less than 0. Okay, so that means that you know that it's always going to be greater than 0. So you don't have to say this, but you could say it, that the interval from 0 to infinity of f prime of x will always be positive. Okay? So you have 5 choices, A, B, C, D, and E. And so if f prime has to always be positive, then what's the connection between f prime and g of x? Well, we have this right here. So if f prime has to be positive, what we're really saying is that g of x has to be positive. Okay, so look at all your pictures of choices for g. Okay, A is always positive. B is negative. It's below the axis, so take B out as a choice. C is always positive. D has a little piece that's negative, so take that out. And E has some that's negative, so take that out. Oops. Sorry about that. Okay, so you're down to A and C as possibly choices. So I think the easiest way to do this is to just take some value and just test it, because what you're trying to find is when is you want to make sure that f prime is equal to g of x. So how I did this was I chose 1, just as like let x equals 1 as an example. And so the question that I asked myself is f prime of 1 equal to g of 1? Okay, if so, then that has to be the answer, and if not, then that would not be good. Okay, so f prime of 1, so I was just picturing like that this was 1 over here. So that would be a positive slope, so I knew this was a positive number. And g of 1 would also be positive. So I got that they would both be positive, they both equal 1, and so so far A is still in the running. Let me just clarify that I don't know if I said, if it was obvious, so you have to look at the picture of A. So let me just go back for 1 second. Okay, so first I want to say, okay, what is f prime of 1? And here's the picture of f. So f prime just means the slope. So I'm looking at 1, and I just pretended that this orange dot right here is when x equals 1. And I know that I get a positive slope. It looks something like 1. You know, I'll say it's questionable. Is the slope 1? Okay, then I need g of 1. So to find g of 1, I have to look at choice A. And when x is 1, it looks like y is probably around 1. Okay, so I keep A still in the running. Okay, now I have to look at C. When x is 1, is y also 1? Well, it certainly looks that way. So, okay, it just didn't work when I tried this using 1, but that doesn't mean you're going to give up. You're just going to try a different value. So I'm going to go back. And instead, I'm going to test now, let's say 0. So I'm going to say is g of 0, I'm sorry, sorry, I put that on the wrong side. I'm trying to follow this one right here. Is f prime of 0 equal to g of 0? If so, then that has to be the right choice. Okay, so what is f prime of 0? Well, here's my picture of f, and when x is 0, here's my y. So f prime of 0 would be, what is the slope over here at 0? Well, it looks like it's somewhere around 1-ish, we'll guess. Okay, now let's look at choice A. What is g of 0? It looks like it's 1. Okay, so A is still in the running. But now let's look at C. What is g of 1? It's 0, but it can't be 0, it has to be 1. So therefore C is out and A has to be the answer. So for these crazy kind of questions, by the process of elimination, that's how you're going to find your answer. Okay, for number 18, this one is supposed to be an easy one. I don't know why everyone had so much trouble with this. This is the definition of the derivative. So you have to consider the limit as h goes to 0 of f of x plus h minus f of x. And you can see it's so clear to see now that f of x has to be ln of 4, but remember you can never use a constant. So f of x must be ln x, where x equals 4. Okay, so if this is the definition of the derivative, then all you have to do is find the derivative of f of x. Okay, so f prime of x equals 1 over x. But we know that x is really 4, so it's just 1/4. And that was choice B.